When we graph, there are things that we have to pay attention to. Okay? Things that we look at are points of interest. Points of interest. That would be our x-intercepts. That would be our y-intercept. Okay? That would be, where's our vertex? Okay? So those are some and any points actually on your parabola. Okay? What are the different forms of a quadratic and what pieces of information they give us? We just did that, right? Vertex form. Man, they give you that h and k, right? It makes it very easy to find the vertex. The standard, you have to work at it, right? So we looked at both of those options. All right, let's answer our questions here. What is the y value of any point on the x-axis?
Are you asking one question?
Yeah. 0, right? And what is the x value of any point on the y-axis?
0.
0. Okay. You have to use that information, right, when we find x-intercepts and when we find y-intercepts. Okay. So here we have our standard form, and we have our vertex form, and we don't see it up here, but you have the intercept form. Okay. So we're going to turn the page, and we're going to start with the standard form. All right. Down here, in any form, if a is greater than 0, right? If a is greater than 0, that means it's positive. So what's that going to do with your parabola? It's going to open. Okay. And if your a is less than 0, that means it's negative. And he's going to open down. Right? He's being reflected. Okay. Now, if we look at the absolute value of our a, okay, you did this with your absolute value graphs. When that a gets larger, what did it do to our absolute value? What did he do?
Goes up.
So that's a what?
Positive.
A vertical stretch. So he's stretched. So he got a little thinner, right?
Right.
I don't.
We wrote it down.
So let's say he gets. You want to say he gets skinnier, narrower, thinner. When your a gets larger, and then as he gets smaller, we're doing what to him? When he's a fraction, we're doing what to him? He gets squished, compressed.
Compressed.
Right. So the graph gets. Do we want to say compressed?
Compressed.
Okay.
What other word would you use?
Well, compressed sounds like a really good word.
Okay, but like what other?
All right. Is this parabola opening up or down? How do you know that? Because it's a positive a, right? It's opening up. Okay. So the first thing we're going to do is we're going to find the vertex. Okay. How do we find the vertex? Remember, we're going to use our
Negative
b over 2a. So remember that good habit we get into? We find our a, b, and c. What's our a?
2.
What's our b?
Negative 8.
And what's our c?
6.
Okay. So let's put that into our vertex. So we're going to do negative. What's our b?
Negative 8.
Negative 8.
Over 2 times 2. So minus the negative 8?
It's just going to be
8 over 4.
which is 2.
Which equals 2. Okay. All right. Okay, so we have part of our vertex. Well, actually we have our axis of symmetry. Come over here to your graph. Find your x equals 2 and dash him in. There's your axis of symmetry.
That's awesome.
That's awesome.
Wonderful.
And that's half of our vertex, right?
Isn't that negative 2? No.
No. Your minus negative 8 comes back as positive 8, and then positive 8 divided by 4 is 2. Okay, now you're going to put that back in to your formula.
What is that next to the 2?
That's the parenthesis.
Oh.
All right, let's go. So we've got 2 times what squared?
2
2 times 2 squared.
minus 8 times
2.
plus 6. What are you going to do first on that 2 times 2 squared?
You're gonna
Square.
You have to, PEMDAS, exponents are done first. So the 2 squared is
4.
4, and then 4
4
times 2
is 8.
It's 8.
minus the 8 times 2.
Negative 16 plus 6.
8,
Wait, where does 16 come from?
negative 8 times 2. Negative 8 times
It's
2.
gonna be a negative 4. It's gonna be a negative.
What's the consensus?
Negative 2.
Are we going to keep negative 2?
Yes.
All right.
I believe I was correct the first time.
Okay. Now, negative 2. So here's your vertex, guys. So come over here. You already have the 2.
Roger.
What color we want to use? 2, negative 2. So you're going to go over 2 and down 2. There's your vertex. There he is.
Over 2. 1, 2.
Okay, your y-intercept. Your y-intercept is your C. Your y-intercept will always be your C. What's our C?
6.
So,
Sarah, I have a question.
okay, so that is at 0, 6, right?
Yes.
Now, our axis of symmetry is the line of symmetry, right?
Right.
So if I count back in from my 0, 6, I'll count back in 2 and I'll count back out 2, and there's my symmetrical point.
What did you say?
Yeah,
Oh, I get it. Look. The line of
Where?
symmetry.
Your axis of
Exactly
symmetry.
the same on the both sides.
Remember your axis of symmetry, your points will be equidistant. So if I put my y-intercept of 6 here, I count back in, I'll count to my axis of symmetry, which is 2, and then I'll count back out, and I've got a point there. Because that's what parabolas do. Like your little warm-up that you did. Hannah?
What is that?
Okay, so we factored out our 2, and then we factored into using our x method, so that would give us an x minus 1 and x minus 3. We're going to set that equal to 0, so what are our 2 zeros? Positive 1 and positive 3. So put those over there in your little chart. Your x-intercepts are at 1 and 3. Let's go ahead and plot those. So here we're here at 1, and we're here at 3.
I knew it was 3. Yeah, I said it out loud. Thanks.
Does he look a little skinny?
Wait, so you do a point at 1 and a point at 3?
Yeah, you get away with
Yeah, it has 2 x-intercepts. Why is he skinny?
It's positive.
That were we stretching him? Yeah, he's being stretched. He's a little stretchy. All right, draw him. Connect your points. Make sure he looks like a parabola. It's going to be kind of hard because he's skinny. He's going to... Yes, because he's a parabola.
Ooh.
Do the best you can. Yeah, mine's a little.
Same.
Now, if you can remember that, if you can remember for parabolas, your domain is all reals, then you just look at your vertex, whether you have a minimum or maximum, and that's how you decide what your range is. Any questions on that? All right, you guys are ready to do the next one by yourself.
No.
Okay, so here it is. Here is your axis of symmetry at the half, and you put that back in and you got 12.25. So here's your vertex. Here is your y-intercept at negative 12. Graph his symmetrical point. And then you can factor that. That factors into the negative 4 and 3, which means you have zeros at negative 3 and 4. And then graph him on up. Okay? Any questions on that?